The discussion today is Tango tools for reliability engineers. I guess the first question that reliability engineers have to ask is what is your reliability today? And so if you don't know where you are, it's hard to figure out whether you're improving reliability. And some of the measurements for reliability are MTBF. That's one of the basics. Availability, I hear plants talk a lot about they've got 80% or 85 or 90 or 95% availability. That's usually an internal measurement that they have their own ways of calculating. But to me, it's just a matter of what was I able to run versus theoretically what can I run, or what is the theoretical maximum. Cost of failure, how much did the failures cost from the standpoint of failure in service, lost production, repair costs. Emergency work orders are another way of looking at reliability. If your reliability is good, then you should be able to plan and execute your work pretty much without emergency work orders. And the percent of degraded assets, or your asset health report. Let's look at some old numbers. These are the best I have available right now, but these are old from about 10 years ago. They came out of an SMRP presentation, and they talk about average reliability versus world class. They look at life of electric motors, that would be the MTBF, and so they're looking at average less than 10 years. I see averages a lot less than that. Sometimes I see averages of 3 and 4 years. World class being greater than 15 years, and that's certainly true. You should be able to get 10, 15, or 30 years out of most electrical motors. Meantime between repairs for pumps, greater than 6 years, average less than 3. Average vibration levels, sometimes you have systems that will calculate a vibration level over the plant or a vibration level over an area of the plant. And he's saying that you should see average levels of less 1 inch per second, average normally greater than 0.3 of an inch per second, which is a fairly significant vibration level, is average. Overtime is a percent of hours worked. Again, world class less than 3%, average greater than 10, emergency work less than 5%, and maintenance cost is a percent of replacement asset value. World class is less than 2%. So anyway, those are just some of the benchmark numbers associated with reliability as presented by others in the industry. What are reliability engineers' responsibilities? I quickly jotted down the ones I could think of. There's probably 2 or 3 times this, but let's just look at where this is. Measurement of current reliability we were just talking about, but you need to know where you are. Develop and administer an asset lifecycle management process. All the way from the time the asset's purchased to the time it's scrapped, somebody needs to be aware of that asset. I find it interesting, might be the right word, that a plant typically has billions of dollars, or at least millions of dollars worth of assets, and really very little in the way of asset management associated with those assets. There's a new ISO standard, ISO 55000, that talks about the asset lifecycle management responsibilities of plants and some of the things they should be doing. If you haven't looked at that, you probably should look at that. Again, develop a strategy to make equipment live longer. That's typically the root cause failure analysis process. Identify high-risk locations and high-risk equipment. So what does high risk mean? It means it has a lot of failures or a low MTBF or both. Develop engineering solutions to solve the repetitive failures. So once you've found a location with repetitive failures, you need to look at why you're getting those repetitive failures and how we're going to make that motor that lives, that is repeatedly failed, has an MTBF of 3 years or 4 years, how are we going to make that motor last 15 years or 30 years? Remaining useful life of an asset, again, it's a hard thing, and some industries and some plants do a lot more with remaining life and budgeted life. Others just do their best to maintain that equipment and keep it running as long as possible. Manage the repair replacement process. We're going to talk about that in another session with Repair Tracker and information and managing your repair vendors, PM optimization, and PDM application. Again, one of the things you're trying to do with PDM is not only know the condition of equipment, but trying to eliminate a lot of the PMs that are scheduled for a piece of equipment by knowing its equipment, by knowing its reliability. And last thing is the reliability metrics. Where do we stand in our reliability program? And give me a measurement along the way so that I know where I am at any given time. This is an equipment life cycle chart that we use with a lot of our Tango talks and information. And so most of the things, while there's reliability things to be done at every step for inventory, stores, repairs, and so forth, pretty much everything we're going to talk about today happens during the period of time that the piece of equipment is installed at a functional location. So today, we've looked at the topics that we can talk about for Tango tools, and we've come up with, I believe, 5 or 6 sessions, hour-long sessions of topics we're going to talk about. Today we're going to talk about identifying and finding solutions to the repetitive and high-risk failures, failures in service, and avoided cost. So let's dig into that a little bit. One of the things that you can do in Tango is once you're putting in your condition problems and you're maintaining the cause of failure, you can then keep track of what are my most common sources of failure. You see that at this particular plant, I've got 80 or 90 mechanical looseness. I've got leaking air gas, rotating unbalance, loose components, bearing wear, and so forth. So again, in this particular plant, I've got a fairly even distribution. While I've got a little more looseness than I've got bearings, I still have a lot of bearing wear and lubrication problems. And so that's telling me where my most common problems are. So maybe I should be looking at what is causing that looseness. Is it internal looseness? Is it structural looseness? Again, if leaking is a issue that's causing me leaking air and gas is causing me a lot of cost, I may want to look into the source of those leaks and start trying to put together a program to solve air leaks. Now, where do you get to these? Your Tango users, Richard, you may not be. The rest, everybody else that's signed on, I think, is a Tango user. How do you get to this information? Let's go there for a moment. All right, so I'm in our demo database. If I go to, this is a plant database that's giving me permission to use their database. And if I go to condition entry analysis, and I run the first report, fault distribution report, set that up. So I got to that same information that we were looking at before in the real database. Again, we've got our mechanical looseness, bearing problems, and if I click on any one of those rows in Tango, it takes me to those specific condition entry cases. Again, we're talking about here dust collector, blast head. So these are the motors that have had bearing problems. Again, I could sort this a little more. Motors, some of them are fans. Looks like by far the majority of the bearing problems are coming out in motors. And so if I wanted to dig into that further, for example, pick one and here are my condition entries associated with that. Or So anyway, that has one open condition entry on the motor. And if we look at where the problem is today on that, it's a small motor evidently. And the structure of the motor base. So it looks like they've got some structural problems in that particular problem or that particular location. And if they went in and straightened out their structure, potentially they'd have better bearing life. All right, let's see if I can get back to the PowerPoint for a moment. So we've got our most common failures. We've got our most common types of equipment that we're seeing those failures on. Again, in the real database, we're looking at 179 motors. So motors have been by far their biggest source of problem. Oil reservoirs, and then airport, pulse air, whatever. I'm not familiar with exactly what that is for them. So we found the type of problems. We found the type of equipment that our problems are happening on. That's one way of looking at the most common problems and looking to see if there's any patterns there. There's a risk report, and I can run that, and the risk report's going to now give me the locations that have the highest risk for failure. But I can take that risk report and sort the column for case count. And when I do that, I'll get something like this. And so even though this location isn't currently a high-risk location, it's had, this particular one's had 10 repetitive problems. This one's had 9, this one's had 7. So if I'm looking specifically for locations that have repetitive problems, then I can take this and then by going into the options, look at the condition entries for that. When I look at that information, I'll get essentially two sets of information. One's a lifespan chart. This is showing me that they had a set of problems in 2012, another set of problems in early 2013, another set of problems in late 2013. And so so you get an idea of what the lifespan chart will show you is as you have multiple problems spread out over a time frame, you'll be able to see where those are and what they are. Then down below that, in the history, you're able to go in and look at each individual case. So let's look at how that works in Tango for a moment. The risk chart or risk report is under services. Under condition risk factor rating report. And so given the logic of this report, it believes that the 10-ton hoist currently has a high level of severity problem. It's an oil problem, and it's, according to the logic, it's our highest severity problem. But if I take this case count column and sort it where I got the highest case count rather than the highest risk, you can begin to see I've got 10 cases, 7, 6, so forth. Any one of those, if I open that, go to condition entry details, there's a photograph of our piece of equipment. Let's go to show closed entries. So now I've opened up all the history rather than just the current history. And now if I go to lifespan chart, the lifespan chart is going to show me where these cases have been over time. And then the history is going to show me that for case number 2077, replace fan shaft, fan bearings, bearish fail in service, seeing vibration before failure. So that's actually an in-service failure, vibration inspection, visual inspection, belts need to be replaced. So you get a whole history of everything that's happened on this machine over since 2013, 2014, 2016. So again, a number of problems have happened on this machine. You as a reliability engineer, saying that this has had 6 problems or 6 case entries over the last 4 years, what should I do about that? And so it's now time to look at these and see if there's any sort of pattern. Obviously, I've got bearing problems, I've got belt problems. I might want to look at this a little harder, more belt problems, another vibration, tighten belt. I might start looking, do I need some belt maintenance? Do I need to have a better belt tensioning procedures and tools? Is my belt shiv alignment good? That sort of thing would be some of the first things I'd start suspecting on this type of machine. Another way that I can look at problems or look at locations to see if to see where the low-hanging fruit is, I guess is the way I'd term this. Where can I get the most payback for my work as a reliability engineer in solving problems? And so one way to do that is to look at the cost of replacement, parts for repairs. And so Tango doesn't keep track of labor hours or production downtime unless you're doing the cost tracking part of Tango. What in this particular report, all we're keeping track of is the cost of the repair, cost of the replacement motor or pump that's going back in that location. So if I look at this area of the 170 compressor room, 2 Syntac has had 3 repairs. It's had an MTBF of 1,207 days, and it's cost me $19,000 over that time, over those 3 repairs. If I go to 3 Syntac, it's only had $4,000 of repairs. It's had 3 repairs though, and it's got an MTBF of 800 days. This is just telling me that it's had some repairs, but they've been minor compared to 2 Syntac, which may have had a whole motor replacement versus some more, on 3 Syntac, more minor things. I go to 1 Syntac, it's had 1 repair, it's got an MTBF of 2,200 days. So 1 Syntac is my most reliable out of the 3 centrifugal compressors that are in this location, in this compressor house. So again, that's another way of looking at it. If I wanted to look at that a little harder, I might say that 2 Syntac would give me my best payback for going in and doing some reliability analysis to see what its failures have been. Again, how do I get that report in Tango? Let's go in, and this time we're going to use our demo database because it's got good equipment information. If I go to equipment, tracking, and I do a report for the equipment repair analysis or location repair analysis. That was our location report I just gave you, just showed you in the PowerPoint. So let's run that, and you see now I've brought that real report up. If I go to the 170 compressor room, I can start opening that up. Air. Two Syntac with its 3 repairs for $19,000. The motor is where those, obviously this has got a motor and a compressor at that location. The motor is where the repairs have been. And here are my 3 repairs, Flanders, Rockridge. And if I went into, I could at this point click those and go in and look at the repair details to see what was done to that piece of equipment for any of those three times. Now, to do this, a lot of you may only be working with the condition side of Tango, where you're maintaining the condition at a location. To get this information, you have to be doing repair tracking, and you have to be doing equipment management, motor management in this particular case, or managing that equipment through its life cycle. So that's a little more work in Tango, but at the same time, you can see that the payback for doing that is fairly significant. Just other reports in the same area. My location reports, if I drill down to the 170 compressor room, it's telling me that 2 Syntac has had 19,003 repairs, MTBF minimum of 135, maximum of 176. My 2 Syntac, again, same information, just presented a little differently. If another way I can run the analysis is, what are my worst offending pieces of equipment? If I have specific motors and pumps and they have an ID number, if they're serialized, I may find that in this particular case, tag number 1751 has had $1 million worth of repairs all by itself. It's had 5 repairs. It's lasted on average a little less than 2 years, 1.5 years really. 1751. Well, let's look into that for a moment. 1751, 1751, find. It's in stores right now. We go to a history report. It's a DC motor. It's probably a very large DC motor, considering the fact that it's had that $1 million worth of repairs. So again, I've got a history. It was repaired in '86, repaired again in '92, repaired in '96, repaired in '97. It's in stores. This is an old demo database, so we don't have history after '98 or so. But you get the idea of the fact that it's been installed, fell fairly quickly, then been repaired. Let's go up this report for a moment. Equipment. This is a Westinghouse 7,000 horsepower, 40 RPM. So this is probably a hot mill. I'm guessing a hot mill motor. Real slow, real big, and if you've ever been in a hot mill, as those ingots go through, it gives quite a jolt to everything. All right. But anyway, that's giving you, again, more tools as a reliability engineer. How do I find the problems? How do I find my worst problems? And then how do I dig into those problems to look to see, is there anything about that engineering-wise we can do better? And I'm going to shift gears for a little bit and talk about failures in service. You saw out of the Mueller database that one of the entries they had was the fact that they were documenting a failure in service. And so, again, I'm going to preach a little bit. If you're not doing it, one of the things you should do is always maintain information on anything that fails in service, because that's a failure of your condition-based maintenance program and your monitoring techniques, or the fact that maybe it's a critical machine, you didn't even have it on the program, or you didn't have the right technology supplied. So anytime a piece of equipment fails in service, causes a production disruption, production downtime, then I want to get into that piece of equipment, and I want to add a condition entry with a failure in service technology. So if you don't have it turned on, one of the things that in Tango you can do is turn on active technologies. One of the active technologies is failure in service. So if that's not turned on in your database, you need to do that. So turn that on as a technology. Then when you document the failure in service, document it with the failure in service technology, document the problems you had with the faults and recommendations and so forth. And then go to the cost section where you're putting in the avoided cost information and put in your cost of that failure versus what it would have been if it had been caught in time. And you have documentation, again, for use later that yes, we missed it, it cost us a bunch of money, and if we did these other things, better monitoring, better tools, whatever, we could catch it in the future. And so most of the time you're trying to document your saves and how much you saved in your program. But if you have failures in service and they're substantial, you want to document those, and you want to document what they cost, and again, what you can save by if you can avoid those, and you can do what it takes to avoid those in the future. It may be things like installed sensors. It may be online monitoring, and which have a considerable price tag, but the price tag may be worth it. All right. We've had whole sessions on avoided cost calculations. One of the things that you can do in Tango is maintain information on what this cost to fix and what it would have cost if it had gone into failure. I'll very quickly show you where that is in Tango. All right, sorry guys, somehow I muted that, and now we're back on. So for condition entry, when I've done a checkoff, the cost tracking is now available to me. If I click the link there, that takes me into an editor or an interface that lets me document. But if I fixed it before it failed in service, so if it run to failure, I can put that in. It's a proactive fix. I fixed it before it failed. I can document that. Any sort of comments about it. But what I'm doing is putting in my actual cost in terms of labor, parts, production, and what it would have cost, in this case, what it would have cost if it had gone on to failure. Of course, if it had been a failure in service, actual cost would be higher than projected cost. Projected cost would be what it would have been if I'd caught it before it had failed. All right, so that takes us through the material that I planned to go through today. Again, back to my topics. You know, repetitive high-risk failures. How do you identify the fact that I've got a repetitive failure or a high-risk failure? And so there's any number of ways to do that. You've got the fact that it's failed multiple times, got multiple cases, the fact that I've got a low MTBF, the fact that I've got a high cost of replacement or repair. So any of those things are going to identify locations where applying reliability engineering talent and tools and focus are going to give me payback. I've got failure in service items. That means that this piece of equipment's failed and I wasn't able to catch it with my program. It could have happened in a number of ways. The worst would be that I caught it, reported it, and nobody fixed it before it failed. That's a communications problem. Obviously it needs to be documented. Other possibilities may be that I didn't apply the right technologies, I wasn't applying them often enough, and so I want to find those. Could be that I wasn't applying any technologies to this piece of equipment and it failed. And it turned out you didn't know it was critical or as critical as it was until it failed. And the last thing we want to talk about was avoided cost, maintaining information on what it costs to repair this piece of equipment, what it would have cost if it gone on to failure. We've kind of hit the topics I wanted to cover today. Let's see who. You guys have anything that you want to discuss, or any questions, or anything that you want to look into in more detail? All right, guys. Well, thanks, and good having you on.